So, here we go. Question about this equation. Remember, this is no calculator. It says, what points are furthest from the pole? Well, you should know what shape that is. What shape is that? That's a rose, a flower, right? This is a rose. And so the points that are furthest from the pole will be the ends of the leaves, right? Wherever the leaves are. How many leaves does this one have? 3. So there's going to be 3 points that are furthest from the pole, and they're going to be the ends of those leaves. Now, let's start at 0. What happens if you put a 0 in there? What is 3 times 0? 0. Cosine 0? 1. 8 times 1? 8. So at 0, think of this as my 8th circle here. I'm out here. So don't I have a leaf right here at 0? In fact, won't I always have a leaf at 0 if it's a cosine? Yeah. All right, so there's my first one. There are 3 of them, evenly spaced. So how far apart will they be? How far apart will they be? What? 2 pi over 3. So if the first one is at 0, think of your ordered pairs. So the first one is at 0, and it's out here at 8. The next one is going to be at 2 pi over 3. Would you agree with that? And it's also going to be out here at 8. Where is the next one going to be? 4 pi over 3. And it is also, going to be out here at 8. So what are the 3 points that are furthest from the pole or furthest from the origin? Right there, those 3 points. Does that make sense to everybody? Not hard at all. Okay, now we gotta solve this equation. All right, here we go. Different frame of mind. This is straight trigonometry, no polar stuff. All right, here we go. So what are we gonna do to solve this? Subtract. And divide. Now this is no calculator, so of course I'm immediately going to think about my unit circle, because if it's no calculator, it's going to be something, one of my specials on there. Now be careful, if I'm thinking of this on the unit circle, then I kind of have to translate this like this. Does that make sense to you? That my coordinates are going to be 1/2 and root 3 over 2. And since it's cotangent, it's x over y. So I'm thinking on my unit circle, forget the negative for a second, where is x 1/2 and y root 3 over 2? What kind of angle is that? Well, it's pi over 3 is the base angle, but since it's negative, I'm over here at 2 pi over 3, or 5 pi over 3, because that negative doesn't have to be in the top, it could also be in the bottom. So what are the answers to the question? 2 pi over 3 and 5 pi over 3. Does that make sense to everybody? Oh gosh, there's a lot to remember. Okay, speaking of a lot to remember, let me simplify this. Cosine and sine, and all of them, are not distributive. So you're not going to say cosine x plus cosine 3 pi. That isn't how it works ever. So what do we have to know? It's on our need to know sheet. What do we need to know? The formula, or called identities, for cosine alpha plus beta. So anybody have to remember it? Cosine x, cosine 3 pi, minus, yes, minus. Yep. Yippee! Yay! That's absolutely awesome. Now, what is the cosine of 3 pi? You can figure out a number for that. Where is 3 pi? Here's my unit circle. Where is 3 pi? Right here? what's the cosine over here at 3 pi? -1. So this is going to become negative cosine. Would everybody agree with that? There's cosine times -1. All right, what's sine 3 pi? So that's gone, so this is the answer, negative cosine. Okay? Get to do it again, but this is a sine. Anybody want to give me that one? Sine pi, cosine x, minus cosine pi, sine x. Yep, that's it exactly. Remember, in the sine formulas, the signs are the same. S, 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 S. All right, here's, oh, pi happens to be that same point. So what is the sine of pi? 0, so that's gone. What's the cosine of pi? -1. So this is going to become just positive sine because it's minus -1 sine. Is that okay with everybody? Perfect. Now we're going to sketch. We've been doing a little of this recently, so hopefully it's not too hard for you. Alright, so we've got -4 tan 2x minus pi over 1. Just to refresh ourselves, do you remember what a tangent curve looks like? Just a regular tangent. Y equals 10x. A little squiggly. And the little squiggly goes through the origin, increases through the origin, and the asymptotes are at negative and positive pi over 2. So that's what I'm starting with. Now, I'm making some changes to it. So first thing I'm changing is it's going to be upside down. Steepness is going to change. I'll deal with that in a minute. Period's going to change. So now my asymptotes, instead of being pi apart, they're going to be pi over 2 apart. And my little squiggly is not going to go through the origin. It's going to go through the point pi over 11. So here's pi over 11. There's going to be an asymptote over here and an asymptote over here. And the distance between those asymptotes is going to be pi over 2. Because you told me my period now is pi over 2. Correct? So how am I going to find where these asymptotes are? Add and subtract pi over 4. This will be pi over 4, and this will be pi over 4. Does that make sense to everyone? So pi over 11 plus pi over 4. I guess my denominator is going to be 44. So what have I got? What is that? 15 44ths. And if I subtract, it'll be -7 44ths. Now, what is halfway between 1 and 15? You don't have to label this, but just for fun, what's halfway between 1 and 15? Halfway between 1 and 15 would be 8, right? You add and divide by 2. Okay, so 8 44ths in here. You don't need to know that, but halfway in between, you're going to go up or down, in this case, down 4 units. Remember? Under normal circumstances, halfway in between, we go up 1 and down 1. But this one's been times by 4. So halfway in between, we're going down 4 and up 4. My scale is terrible. Down 4 and up 4. It's asking me. And then I draw my curve. Gotta go through that point, and that point. And now, okay. A normal tangent would only go up 1. So a normal tangent would be a lot curvier. Does that make sense to you? Be a lot curvier. This one is straighter because you stretched it by a factor of 4. All right, 3 sine. All right, so now we've got a regular sine. We've done a lot of those the last few days. So we know what that looks like. It has a midline at -1. A phase shift of -pi/10. Just going to start right there. At -pi/10. And a period of what? 2pi/4, so pi/2. This is the starting point. I need to add pi/2, so -1/10 plus 1/2 is what, 4/10? So there's 1, 0, there's 1/10, 2/10, 3/10, 4/10. Trying to keep my scale a little bit nicer here. All right, I know my amplitude is 3, so I'm going to go up 2 and down to -4.
Oh wait, I forgot.
Okay, now I need to figure out my labels in here. So what is right in the middle of -1/10 and 4/10? What's right in the middle of that? This is 1/10, this is 2/10, this is 3/10. All right, so what's right in the middle of my beginning and my end? What's right in the middle of -1 and 4? 3/20? Is that right? So 3/20 would be like right here. So that's my middle. So what is right in the middle then of -1/10 and 3/20? What's in the middle of those two? No. This would be -2 and +3. So that would be -1/20 divided by 2 would be -1/40. No, +1/40. So here's pi/40. And that's where I am up here. And then what's halfway between 3/20 and 4/10? That's 12, so this is your 11/40 right here, and that's where we're down here. So there you are just avoiding because fractions are involved. That's part of life, guys. Oh my goodness. These are need hard fractions. But there's the sign curve. It's positive. Yeah. Okay? All right, back to 4. Find rectangular coordinates for -5 pi over 3. So that's r and theta. We are going to find x and y. How do we find x? What's x? What's x? R cosine theta. And what's y? R sine theta. Do you know the cosine of pi over 3? I hope so. Cosine of pi over 3 is 1/2. So this is -5 times 1/2. So -5/2. And what's the sine of pi over 3? Root 3 over 2. So that's -5 root 3 over 2. There are your rectangular coordinates for -5 pi over 3. Think about this for a second. Where's pi over 3? What quadrant? Quadrant 1. But we put a -r on it, which is going to flip it over into quadrant 3. And look what happened to your x and y. See how your x and y are both negative? They're in quadrant 3. That point is in quadrant 3. All right. Average rate of change. Huge topic in all 3 units. Probably going to be one on the exam. Don't know which unit it will come out of. But if it comes out of unit 3, then it might look like this. So, average rate of change. R of 7 pi over 6 minus R of 0 over 7 pi over 6 minus 0. Would everyone agree with that setup? Okay. So now we have to figure out what do we get when we find R of 7 pi over 6. So R of 7 pi over 6 will be 5 cosine 2 times 7 pi over 6 minus sine squared 7 pi over 6. I don't know what you're doing. Let's focus here. All right, what's 2 times 7 pi over 6? 7 pi over 3. Okay, what is the cosine of 7 pi over 3? 7 pi over 3 is the same as pi over 3, isn't it? So the cosine is 1/2. So this is 5 times 1/2, or 5/2. All right, what is the sine of 7 pi over 6? The sine of 7 pi over 6. -1/2. But we're squaring it, so -1/2 squared would be 1/4. And that's over 7 pi over 6 minus, oh wait, I'm not done. That's only the first part, never mind. So what is this? What is this? I'm still doing just this. What's 5/2 minus 1/4? 9/4. All right, so this guy right here is 9/4. So 9/4 minus, okay, now we're gonna do it again. I'm gonna put zeros in. What's the cosine of 0? cosine of 0 is 1, so this is just gonna be 5. Everybody okay with that? What's the sine of 0? 0. Squared is still just 0. So r of 0 is 5. And that is the whole numerator, and that's over 7 pi over 6. All right, so let's get common denominator here. What's that numerator gonna be? 9? Negative 11 over 4 divided by 7 pi over 6. So we can do negative 11 fourths times 6 over 7 pi of 1. Cancel a 2 out. So it looks like our answer is going to be what? Negative 33 over 7 pi. And if that were in a word problem, it would have a unit. It's a slope, so it has a unit. It would be feet per radian. Oops, what did I say?
Would it be 14 on the bottom?
Wait, what did I do?
I think the answer
Oh,
is-
yeah. I have a 2 there. I just didn't write it down. Thank you. What did I write? That's right. 14, 2 times 7. 2 times 7. So that would be feet per radian or something. Per radian. Alrighty, next, another solve. This one is with the calculator. It says solve with the calculator. And all that means is that the angle's not going to be special. All of these problems can be done on the calculator, but you have to do it when the angle isn't special. So let's see what the angle is. All right, what are you gonna do here? We're gonna move 5 and divide by 3, so let's see, that will be 41 thirds. Definitely not special. I don't have a cosecant button on my calculator, so I'm gonna rethink this. This sign is 3/41. Does that make sense to you? Now, before I go to the calculator, where is that gonna happen? Where, not specifically, but just location-wise, which quadrant am I gonna have a sign that's a positive 3/41? Or 2. This could be quadrant 1 or 2. It's like having a pi over 3 angle in 1 or 2. Only it's not pi over 3, it's what? Second sign, 3/41. I got 0.073. Is that what you got? So what are the answers? Well, in quadrant 1, it is 0.073. Would you agree with that? What is it in quadrant 2? How will I do that? Yep, subtract from pi. So I got 3.068. So this one is going to, this angle is going to be pi minus 0.073. Now I have to be careful because whoever wrote the worksheet, me, didn't give you any directions. So actually, if the directions had been as they have been on a lot of problems, this, then that would be the answer. But since I didn't put that in, what do I have to do? Plus or minus, yeah, you gotta go. Gotta go all of them. And you have different ways of writing that, it doesn't matter, you can do integers, just do the plus and do integers, but we need all of the angles because we didn't stipulate otherwise. find the polar form of this number. So I need polar, so I need an R and I need a theta. I have an X and a Y. This is what I have given to me. I need an R and a theta. So what's R?
116
Square root of 116, right? Which might break down, so I'm gonna go ahead and see if it breaks down. I know it's not perfect square, I know, but 2 root 29. I don't know if we need to do that or not, we'll just do it. We have time. Now I need theta. Can I find that angle?
Can you just do like the tangent of
Second tangent, 4/10. And that angle is 0.381. Now there's no specific directions about theta in terms of positive or negative. So could I say 2 root 29 cosine negative 0.381 plus I sine negative 0.381? Would that be an acceptable answer? Yeah, gotta have the negative, right? Because positive would be up here. What would be another one? What would be another possible answer? Instead of doing negative 0.381, we could find the positive angle, and what would that be? 5.903? So that would be another one. The point is here, simply writing 2 root 29 comma 5.903 isn't good enough because the problem has an I, so your answer has to have an I. These are polar coordinates, same arc, same theta, but you gotta have an I, so you gotta write it in this form. Okay? All right. Take a couple minutes and number 11 is all unit circle. So take a couple minutes with your partner and see if you can find the answers to number 11. They're all unit circle, there's a couple of like more complicated ones in there, but straight from the unit circle, can we do this?
yeah, because he can use numbers.
There should be no calculators on these problems.
cosine though. Yeah, yeah. So then you just flip it to in the denominator. Yeah.
It's like only $2.
Yeah. It might be. Like odds on. Oh, that could be.
E equals MC squared.
Doesn't it? You've been dialed in still? Oh, been dialed in still or not? Yes. You remaking that play? Fair. It's just kind of flattering. It's expensive. It's like double. I'm gonna slide there. Galdi, not slide. Worst case, I might have to with my grandma because no one else slide. What are you gonna do? What you're gonna say? Oh, yeah. What's he gonna say? So cool. What's that? Oh yeah. It's so bad. No, it's tough. It's tough.
All right, let's do the first
It's
one.
funny as hell though.
Anybody get an answer for A? 1/2? Everybody get 1/2 for that one?
Yeah, we're not like
What's the
that.
sine of 11 pi over 6?
Clearly
The
don't
sine
know.
of 11, if your unit circle, the sine of 11 pi over 6 is not -1, -1/2, yep. Okay, what is the tangent of 5 pi over 4? Positive 1.
We're so
Third
close.
quadrant, it's in the third quadrant. So -1, so the answer should be -3/2. Now, somebody said negative, somebody said 1/2 or something, and you all agreed.
Who said that?
Rasheed.
We gotta talk about it, all right? If you didn't match, I hope a bunch of you didn't match that.
We got that
All
right.
right, what's this say? What are we doing here? Which is find the angle that has that tangent. So remember, when you are inverse tangenting, you're on this side of the unit circle only. And if it's a negative, you have to be down here. So somewhere down here, there is an angle that has a tangent of 1. 1/1. The only time X and Y match is with a pi over 4. And it's down here, negative pi over 4. Did anybody say 7 pi over 4? If you did, you forgot that you have to be in only this part of the circle and you can't move out of that. So it's like the rest of the grid isn't even there. So you need to get to here, but you can't go over here. So the only way to get there is to go down. You are restricted to here with an inverse tangent. You can do it either way. I use parentheses because the tangent of pi over 2 is undefined. So your answer is never going to be pi over 2, but for all the rest of them, we would bracket it. All right, secant 15 pi over 4. that's too big, so let's shrink it. What does it shrink down to? 7 pi over 4. When I want to shrink an angle, that means I want to leave it in the same spot, get rid of extra revolutions. So what am I getting rid of? 2 pi, 8/4. All right, that happens to be this angle right here where we just were. This coordinate is √2/2, negative √2/2. I want the secant, and the secant is the reciprocal of the cosine. So 2/√2, this one has to be simplified because it breaks all the way down to √2. √2. Good? All right, what's this? The angle whose sine is -1/2. That one is in the same place as the tangent. What angle has a sine of 1/2? Pi over 6. But it's negative. So this is negative pi over 6. What angle has a cosine of -1/2? Cosine's different. Remember, cosines are up here. This is cosine. So I need an angle over here that has a cosine of 1/2. So what is that? That's pi over 3 in the second quadrant. So 2 pi over 3. And then I'm gonna subtract them. So I think -5 pi over 6, does that look about right? There's a lot of review in that problem. All right, cosecant 5 pi. Where's 5 pi? Here's my unit circle. Where's 5 pi? Right here? What's the cosine? What's the sine? Excuse me. What's the sine over there? The sine is 0. I want the cosecant, which is the reciprocal of the sine, undefined. And then this last one, what did you do with it? What did you do?
Add 2 angles.
Okay, did you find 2? Well, that's what you need to do. You could subtract, add or subtract, but you need 2 of your unit circle angles that add up or subtract to 1 pi over 12. Did anybody find one? Guys, did you find them?
Can it be like 7 pi over 4 if you want?
Can it be what?
7 pi over 4 if you want, or
Oh, no, yeah, sure. So you get 7 pi over 4 and
pi over 3?
minus pi over 3. So this would be, how many 12ths is that? 21 12ths?
Wait, I
That
got
isn't gonna make 11 12ths, yeah.
2 pi over 3 and pi over 4.
2 pi over 3 and pi over 4. So this would be 8 12ths, and that would be 3 12ths, which makes 11 12ths. There are other combinations, but that's one that works. 2 pi over 3 and pi over 4. So quickly, this would be cosine 2 pi over 3, cosine pi over 4, minus sine 2 pi over 3, sine pi over 4. Then you would find all those numbers and do the math, right? Okey dokey, so these. Listen,